And it says we're live. Welcome, everyone. This special edition of Investigating a Little Bit of Science. We are exploring the hyperbolic universe with Mr. Thad Roberts here. Say hi to everyone, Thad.
Hello, everyone.
All right. And this is an extremely interesting story. And much of the content I've been putting out probably over the past 4 to 5 months or so, I've been making a lot of references to Thad and some of his work. Like, he's how I was basically able to start to calculate the Planck time the other day. It wasn't that I did any of that. It's just he basically gave me the equations, and with a little bit of counseling the other day, I found out that he wasn't even using the paid version of Wolfram Alpha. I just put a bracket in the wrong way. And then quickly yesterday, I'm like, oh, I completely did that right. But how I came across you, and this is just very interesting, just in my opinion, the world is literally, it's more complex and interesting than fiction itself, because I'm just going around and I kind of started listening on Joe Rogan, of course, because that seems to be the center of a lot of this internet of stuff and things. And I see a Dr. Eric Weinstein on at one point. He starts going into like twisters and stuff. He's like, you could, for these particles to get realigned, they need to actually go around it twice. And I'm like, Nani? What is this guy talking about? I found that fascinating. So I started following him about a bunch of these things, and I found Professor Brian Keating. And I think either you would follow Professor Brian Keating or you would like something. And all of a sudden I'm like, oh, look, a theoretical physicist, Thad Roberts. I'm like, all right, well, let me follow this guy. I like that type of stuff. And one day I was just going out for a run. I believe it was on April 6th. I know it was April 6th because I was out for a run. And all of a sudden I see this tweet and I'm like, source code 7. I'm like, this is this physics gentleman. Let me click on this. And I'm listening to the premiere. And as you're going over your analysis of the hyperbolic figure 8 knot and its complement, I'm just listening to this all. I'm like, if half of what this dude is saying has any semblance of actually being true, this is revolutionary. And a little over 12 hours later, I'm at work. They announce the results of the muon G2 experiment. And I'm listening. I'm like, that's kind of cool. I think I tweeted at you, and I'm like, does this help your analysis? Yeah. And you're like, yes. I go home. I go back to the point in the video where you had made your muon G2 predictions. I look at the Fermilab results, and I'm like, dude, man, nailed it. Dude, man, nailed it. It was freaking amazing. But now, how did you end up coming upon this? Because I remember in source code 7, you literally just went back to the beginning. You literally just went back to the Platonic solid. So I was just wondering, you could maybe kind of give the folks just kind of like a quick rundown about like your just process of thinking about this.
Well, I'm not sure the path is a quick rundown. It took 20 years. And it was a process of trying to question the foundational structure we have in our assumptions, right? I mean, literally from what the world is, what's the logic that we're using to reason to begin with. So my intuition was very strongly aligned with Einstein's ever since I was exposed to him. So I kept pushing in directions, hoping for some sort of model that would make more sense of things. And I think in Einstein's intuition, I think you see exactly where my intuition made its reach for, right? Since then, or since publishing Einstein's intuition, I spent 10 years re-asking the same questions, trying to look things up, thinking, hoping maybe I made a mistake, maybe I missed something. I'm looking for something. I was just running it into a dead wall, right? I couldn't make any progress. There was no new insights of new questions. I had a list of valuable questions with no answers, right? And that's basically where we're at with physics right now. We have an investigation we've made of the world, and we've been able to parse that investigation down into very specific pieces. The world's composed a very specific way, all made out of atoms, and those atoms are almost all just electrons, protons, and neutrons. But if you look really closer, you've got other particles too, but not an infinite set, not even a large set. So the whole world is fundamentally composed of very specific things. We've measured the properties of these things, right, very consistently. And everyone in the conversation agrees on basically what the fundamental properties of reality now are, right? Of the things, maybe we haven't observed them all, maybe there's things that we will still discover later, but of what we've observed so far, it's a pretty clear picture of what the fundamental parameters of reality are. By pretty clear picture, I mean, we can agree on the set of the mysteries, okay? There is no picture for quantum field theory right now. There's no geometric import that you can put into your brain about what it's supposed to look like. Nobody's there. Nobody. And it's not that you just don't understand quantum field theory. It's that it isn't understandable that way. No one's ever explained it with its geometric picture intact. Okay. So the place we're at right now is we're at a description of what the world is, and a mathematical model that allows us to, once we skew things by these parameters we've measured, reproduce all the actions that we observe in the world very accurately. So we believe that the model is telling us something genuinely real about what reality is, right? The problem is every single one of the parameters that skew this model are completely unexplained. There's no story attached. There's no hint of what's going on. They're just these numbers that we've measured, and there's been no explanation past that.
It's very interesting because, as you're describing, we've observed these things. We've taken measurements. We have all these numbers. We don't know why they're the numbers, but when you just start breaking it down, and you, based upon your explanation of that, if you break it down into mass, length, temperature, charge, and time, those are the 5 fundamental, did you say deformations is how you refer to them as?
Dimensions.
Different dimensions. Okay.
Yeah.
And just as soon as you kind of started drawing those things out there, and even one of the things I used for the thumbnail here was the point where you had those 5 different circles. You had your base 0, and then you had your 5 substantiation points beyond that, which to me is I believe we never know where a good idea may come from. And one of the reasons I share this, just as a quick 15-second aside, I happen to be on one of the unofficial portal discords that happen to follow Dr. Weinstein. And at one point there was a gentleman who was given his quote unquote theory of everything. He was going on, and general consensus from the folks in that chat is dude may have been having a minor mental breakdown at the time because he was getting all emotional about these things. But the one thing I remember about that, he said, it shall be revealed by using 5 rings. This was about 2 months before I saw your source code 7 video. And I just sit back and I'm like, that's very interesting. I don't know. I don't know. Again, the universe works in absolutely mysterious ways. But
don't you feel like this actually offers a huge demystification of it? Like, if we have the explanation, so we have a base geometry here, right? We'll get into what a manifold is, but right now it's a geometry that's self-closed, it's self-stabilizing, and the simplest possible one, okay? Once you get that picture in your head, I mean, don't worry about having the picture yet, but imagine when you have a geometry that has 5 properties, it just has 5 properties part of it always, and you can explain the dimensions of reality in terms of those 5 properties. Yeah, that's kind of confusing because this is just the knot itself, not all the projective complement inside or outside, right? So what's really important about the minimum geometry is that it's subdividing and rotating those subdivisions into itself. So it's a manifold, it's a geometry whose boundaries been removed. Let me try to be more detailed about that. A 2-dimensional sheet of paper, okay? It's 2-dimensional. It's not a manifold because you can be going along the surface and fall off the edge, okay? To make a 2-dimensional surface into a manifold, you have to remove the edges. So you have to curl this up and contact those together, right? Connect them. Those 2 edges are gone. And then hopefully if it's rubbery enough, you could take the now circular edges and bend them together to make a torus. Then that 2-dimensional geometry is now a manifold. It's a geometry whose boundaries have been removed. And you can do that always by self-intersection or Mobius, right? So those are our options. You still there?
Yeah. No, sorry. No, I was putting you were displaying that there.
Yeah,
I realize it's a bit of a different technology, but that was one of the things that I actually picked up even more recently, because at least as soon as you show that picture, just the hyperbolic figure 8 knot, I at least have some semblance of, to actually figure these things out, you need to go with its complement as well. But from what I understand, is it's basically the smallest fully enclosed balanced manifold there, and just even more recently, it just kind of clicked. I'm like, wait a sec, the whole thing is basically a Mobius strip. as well. So basically, you literally need to go all around all the outside as well. So that adds an extra degree
Actually,
of intricacy.
yeah, exactly. The connection between the inside and the outside. So this thing's divided into an inside that's doing something and an outside doing something, and they're mirrored, so they're complementing each other, right? But that division boundary is the thing we're clearly seeing. I just forgot what you just said at the end there, so say that again.
Oh, no. It was the smallest balanced manifold. And then, of course, with the wonderful internet, I was able to go onto Wikipedia, and I'm just looking on it. And just the way you describe the interactions as well, 2 internally and 3 externally. And again, maybe I'm just looking for reasons why these might be the case. But I'm pretty sure those are the 2 smallest numbers of prime that we know of as well.
Okay,
so I mean,
okay.
I realize it probably doesn't mean anything, but
Well, it turns
cool.
out actually, since this is a structured theory of derangement, it's literally a minimum condition for balanced derangements, right? Derangements are automatically, by definition, connected to the conversation of primes. So that's eventually going to be where I mean, I'm a physicist originally, or a philosopher of physics too, and didn't intend to go to the primes. But now that this solution has pushed me into a theory of derangements that exposed me to the hyperbolic figure 8 knot. Honestly, I'd never heard of the hyperbolic figure 8 knot before.
I don't think many people have. I literally, when I put it into YouTube, I find, okay, so maybe like 1 or 2 of your videos and like maybe 2 other lectures of folks in the classroom analyzing it. And
Yeah.
I just keep on going back down
There
to
are
it.
more, but I'm surprised that it's not more of a popular topic, because geometry itself is like a thing you can intellectually grasp really well, right? So when there's a concept like a manifold, a geometric object that's special in a way that it's self-maintained, its boundaries removed, right? That you'd think that would be a very common popular thing, but it's not yet. So I think we need to make that a more clear concept. And of course, it becomes a more clear concept when you're motivated to learn it, knowing that literally the structural picture you were missing for quantum field theory is that manifold. That geometry describes the divisions of all the fundamental parameters that define the parameters of quantum field theory, our constructive reality.
I just sit here and I'm like, we're looking for an answer. I'm like, we have an answer. We're looking in other places. Why? Well, everyone else is talking about all these other things. So that's why partially, and again, I apologize. I'm not trying to take away from your work at all, but I kind of am slightly memeing it. And that's one of the reasons I call it hyperbolic reality. Good God, man, whatever you end up calling your research, please don't call it hyperbolic reality. But because that statement is, while it may be accurate, you could also take the other definitions of hyperbolic and reality, and folks could be like, oh, they're just joking. So, which was part of the reason why I did it as well. But we have this thing. It makes predictions. It actually helps explain reasons why we actually come to these numbers that we have measured in physics that we've been spending years trying to figure it out. And I am biased because it's also very beautiful, because after I finished geometry back in high school, there was just always this picture that kind of stuck out in my head, and it didn't have the internal cross, but it was basically, I figured, well, originally back in the day, we represented infinity with a circle. And then basically we had the twisted circle. And I'm like, well, what happens if you did that a 3rd time? And basically all I had was basically just, I didn't have the internal twist there, but I'm like, well, maybe this explains something. And just in my head, back of my head, it was going around. And then I see this and I'm like, all right, well, it's kind of looking like, again, I'm not a trained physicist, but kind of looks like there's like 3 + 1 dimensions, just even within the object itself. I'm like,
let's talk a little bit about what the object looks like on the outside. So in the way I've decomposed it so far, and the next version of the book I have coming out should make this even more clear, but it may have been confusing because I showed the hyperbolic figure 8 knot complement, the internal part, right, and then the external part right next to it, as if they were side by side. If they're not side by side, I pulled the inside out and showed it next to you side by side, okay, to compare them. But the inside is a Mobius. Every circle on the outside, there's 2 circles on the outside. On the inside, its structure is composed of the inside of each of those circles, right? So the connections are made of the same parts Mobiusly, just like you were noticing. However, the external world, since it's composed of 2 different circles, it's technically R4, it's 4-dimensional, because the 2 circles just connected at one point. So they can sweep out 4-dimensional freedom, okay? nevertheless, this thing is highly asymmetric scale-wise. Therefore, one of the circles is much smaller than the other, and they have to be connected chirally. So one has to be rotating, doing something, wrapping up way faster than the other one, which means it binds up two of the dimensions for the other one, only leaving the axis left for its degree of freedom. So the external projection behaves and looks completely smoothly symmetric as three-dimensional. It's a sphere, the great sphere, that's internally composed on the balance of the torus, the Clifford torus, which is the intersection of two circles that's asymmetric. That's the external projection. The internal one is exactly the shape you've seen. And those two shapes are Mobiusly connected. They're, well, actually under inversion and twist connected.
So we got the torsion in there. Now, is this basically how you've kind of laid out with those 5 circles before and those different points, how we kind of transition from one to the other?
Well, the 5 rotations are always all connected, right? You can never separate them. The point is, in the minimal description, or the minimal universe we can describe, which would be this geometry, that geometry comes intrinsically with 5 different major divisions, and we'll call those the dimensions, and the boundaries of those divisions happen to have the exact same values as the Planck constants. The intersections that are all balanced by this entire system between those Planck boundaries give us all the constants in nature. And if you just look at one of the external dimensions, say the charge rotation, then the charge boundary, the way it divides up in this system, gives you all the possible charge expressions. If you look at the mass boundary and look at the way it partitions, it gives you all the mass partitions of reality. And that's it. The entire internal construction builds the universal parameters of quantum field theory, the entire list of our greatest mysteries and the ones we've measured to highest accuracy in science, the mysteries we know best, which now, before this, had 0 explanation whatsoever that worked. I mean, people would try for explanations, but there was never a single one that predicted the electron's mass or the proton's mass or the muon, none of them, right? Let alone all of them at once from one single geometry.
So I got to ask that. Have you solved for universe?
Have I what?
Have you solved for universe?
Have I solved our universe? Well,
no, just for universe, for you. That's why I put it in that way. But this is why I'm amazed. I'm like, I hear people say, you can't calculate the mass of an electron. And I'm sitting here, I'm like, I'm looking at it. I'm looking at it.
It's not even difficult. It's the most simple thing that the mass boundary could be. Literally, when you find, okay, in this balance, this whole thing was a hyperbolic figure-8 knot. It's got an internal construction and external construction, and they're entirely mirrored, so it's self-closed. It's really easy at that point to know, hey, logically, we can pull this thing apart and put all of its parts exactly in their places, define them geometrically. And when you do, you get the numbers that we've been trying to explain before. There's no real, I mean, I guess you could call it magic in the sense that it transitions you from a way of thinking to a whole new way of thinking that you didn't even know was there before. But when you get there, you're like, that seems far easier than, why didn't we already have that idea?
I think it comes down to just noticing, paying attention, and just seeing different causal relationships.
It's hard to step out of the way we think. Yeah, but I've been trying that forever. The big key was, I did get somebody who sent me an email from actually somebody I had never met before, and said, hey, do you know what this conversation online? And somebody had noticed an equation that could close to predict the fine structure constant. And I had been focused at that point for almost a decade on a way to geometrically predict the fine structure constant, okay? Really focus on it. And I'd almost like, I just didn't know what else to do. So they sent me an equation, and this one, it got it right to like 7 significant digits, okay? But we know it better than that. So it definitely missed it for the ones past that. But I had never seen anything get it right past 5 before, right? So it was already 2 orders of magnitude better. And I'm like, this is really interesting. But also the equation itself, I rewrote in the way that I was thinking of things up until then, and it simplified. And I realized this equation is very geometrically simple. I need to figure out what it means. And then it occurred to me, wait a second, what if I assumed it did give the right answer? what would I have to modify the equation by to get the right answer? When I ask that question, that's easy now, right? You can just say, all right, put it in the computer and say, okay, put the right answer in on the other side of the equal sign. And then put the x as the unknown, which you had to modify it by. And it turned out I had to modify it by minusing the Planck mass.
Just just as you're describing it, I'm just going through my head. I'm like, is he calculating these things? And then all of a sudden it goes from this. It's like, all right, well, we got this. Now what happens if we actually incorporate this into the model and it just keeps on just pulling back more and more pieces?
Well, at that point, I realized now I had a way to ask questions and get an answer back. Now I had something that was geometrically connecting to the biggest mystery I wanted, but the way it connected was through the mass boundary. I had not even thought of looking for a way for it to connect to the mass boundary before, right? It was like a big mind-blowing event, but it was also an equation. If you've typed it into Wolfram Alpha before, it's basically hyperbolic. It's the equation for a hyperbola, 1 over x plus x cubed, except for you make it self-closed hyperbola. So you take the x cubed part and divide it by 2 pi, so it goes around a circle. So now you got like a cone going up, and you got a cone going down, and you got a section that wraps around, like our basic hyperbolic geometry, okay? That equation, it has 4 solutions, okay? I ignored the other 3 solutions. I didn't want them or need them. I was absolutely blown away that the first solution gave us something and was trying to understand it. It took me a long time to really realize, hey, wait a second. To understand the geometry of the equation, you have to also understand what the other solutions mean and why they're there and so on. Yeah, I was really baby talk starting at this thing, right? Because it was a new equation. It wasn't something that came from a book that someone else could explain. And it was something that fell out of, well, in this case, someone had directed me to it, okay? So I had to try to make sense of it. Well, when I started realizing that, well, let me back up here. A lot of physicists have the opinion that we can't even look into the numbers that we call the parameters of quantum field theory because they have to be random. There couldn't be any meaning in those numbers because, look, they're in units of meters and seconds and kilograms, and we made those up. I know, it's a face-slapping moment. The whole history of physics is the discovery that dimensions of reality are connected. The speed of light connects the dimensions of meters to seconds with a very specific geometric number that gives us the connection between meters and seconds. We've known that as like a mind-blowing, that's like every one of those mind-blowing, this is now part of physics events, was a realization that there's a connection fixed in physics. And the list of the connections we know of are the parameters of quantum field theory.
It boils down to combinatorics and everything. Yeah, I believe
exactly. And realizing that the base dimensions are the fundamental mystery to begin with, right? The numbers are telling you how those dimensions connect. But why do we have those 5 dimensions to begin with? Before you even get to why they're connecting, why do we have 5 dimensions? Why is it all from just those 5? There's nothing else needed to make sense of our world according to physics, right? All measurements we've ever made can be made from a combination of just those 5, the time, length, charge, mass, and temperature. That's it. It might be a complicated combination of those, but everything we've ever measured is a measurement of those 5, because those are our dimensions of measure.
Now, had you gone back and rephrased them? Because I think in one of your earlier videos I had gone back to, I think you were saying spin at one point, and did temperature end up replacing spin on the calculations, or how did that work?
Maybe I just misinterpreted. I probably said space.
Okay.
Yeah, I interchange the word length and space when I go through that sequence because it's a Planck length, but people usually refer in their head as the length is the field that we're building space from, when technically in this one, we're building it from all 5. You could make any of them the one your preference. Anyway. Okay.
No, we got some folks in the chat there. Like, I know I could see Math Peg, and he's looking there. He's looking at this. I have Thad's link down in the thing below, so if you want to go check it out, I would say either Source Code 7 or The Simplest Universe. I would say Source Code 7 if you wanted to do a full deep dive, because he literally starts off with
The Simplest Universe, because it'll give you the whole comprehensive thing, right? And then you'll have an overview on where it's going. But the Source Code 7 and the newest one coming up is going to even more detailed with more graphs and beautiful pictures.
All I know is I'm glad to have Thad on before Oprah gets him. Because at this point, I can say I scooped Oprah just because I'm looking at this, and once folks get a hold of this, and the other reason why I'm sitting here and I'm like, this is starting to make so much sense to me, because I see other folks, whether it's Dr. Weinstein, whether it's Dr. Wolfram, and the things that they're doing. And so much of it, I'm hearing a lot of the same things. And the big thing, and I can kind of at least take away the difference from the Weinstein and the Wolfram models, is the Weinstein model is based upon an outside observer of the universe. The Wolfram models are based upon an internal observer. And even with the geometric unity, I'm looking at it and what Dr. Weinstein referred to as a Diable graph and everything. I'm like, wait a second. It's basically just two vortices coming down, intersecting. Basically, you have a torus going around the inside and something spinning. I'm like, if I were to basically extend those vortices, it would end up being a cylinder, and a cylinder with an appropriate size sphere will fully, perfectly go over the outside, and you could essentially just twist that into, I don't know, a hyperbolic figure eight knot. And I'm like, I think we're talking about a lot of the same things, and we're just trying to get them lined up so they'll work. And as far as I can see it, you've predicted most everything we've measured.
There's far too little people trying, and not because we don't have good enough people at heart. I think that we have a system that really deters people from actually asking the fundamental questions about reality.
Yeah.
And that's our birthright. That's the only way we advance into something greater, right? You never make it greater on accident.
Well, maybe, but we got to take those quote unquote happy accidents and try to apply them into something useful. As well. That's the thing.
Yeah.
No, and one of the big things is there seems to be a lot of discouragement.
Better said, to feel like we're on a moral trajectory is it's nice to have an intention to where we're going instead of just being dragged around.
Totally agree. But
all right, so he asked, what is the claim? Do you want to give me the overview? What's the short pitch here? What are we saying?
Okay. What are you trying to communicate to the world?
Yeah, I'm going to hear your version first, and then I'll elaborate from there.
Okay. My particular version is, what are the next steps? Because as I slowly feel my mind starting to come to grips with what might actually be based upon your analysis, all of a sudden I get an extraordinarily uncomfortable feeling about my mind shooting out in all these other directions. Be like, well, how would this work? How's it all going to fit together? Is it a form of a lattice? I mean, is this just like the minimal state of any type of unit within the universe? How do photons transfer? I'm like, how do we even exist, man? I'm just like, we're just all this twisted things. Like, how are we moving through the universe? When you have those
questions, please write them down. Those are the most important moments we have personally, or powerful questions about something. And whether you eventually find it wrong or right, that's for me, that's the best thing to follow.
I don't got a lot of answers, but I got a lot of questions. So.
Answers are always found through the question, right? If you don't focus on the question and try to make it sharper and clearer and understand. Here's an example. Einstein was once asked, all right, you have 1 hour, the world's going to end unless you can figure out how to solve this problem. What do you do? Do you remember his answer? Have you heard this?
No, I've never actually heard this story.
He said quite confidently, I'd spend 55 minutes clarifying the question and 5 minutes composing the answer. That's what it is. The questions need to be clarified. And people in the past, our great thinkers of the past, have brought us a lot of clarity of question already. And it's our job to push that clarity further, right? To ask past that. We have new technologies. So all the great minds of the past who didn't have Wolfram Alpha didn't have that advantage. You don't have to think you're smarter than Gauss to think you can discover something he couldn't. You have an advantage he didn't have. Ask all the questions Gauss asked, right?
This was the other thing, because when I was listening to The Simplest Universe, and I just see you just plugging these equations, from what I've seen from listening to all these different lectures and everything, I'm like, I don't know if these seem to be pretty simplified. Even somebody like me that maybe I took modern physics for like all of like 1 week in college because it sounded like a cool class. I didn't realize I needed to have the prerequisites.
Actually, that's a really good point. If someone's not a physicist at all and doesn't even understand anything about the conversation or trying to find a theory of everything, the goal is to find a structure, a geometry, an explanation that we can actually sink our intellectual talons into that explains the world we see. We have observations that need to be explained, and we need a geometry that explains specifically those observations, right? So far, no one's done it at all, not even piecemeal, not a one piece at all has been explained in the sense of Nobody's been able to predict the electron mass from a model that says, here's the reason. And it's just a short little equation. The only way people have done it numerically is just keep adding new terms to adjust it until it gets there. That's right. Nobody's satisfied with that, right? Literally no simple model. If you look at the equation here for now, the electron mass, do you remember what it is?
I don't, but if you give it to me, I can type into Wolfram Alpha right now, because I just brought Wolfram Alpha up.
Two times the volume of the hyperbolic figure 8 knot. It's a geometric number like pi. And actually, let's do that in there for you. Do you know what the number is? Or do you know how to find numbers on Wolfram Alpha?
This is probably like the third or fourth time I've really used Wolfram Alpha.
Type in 2.02988.
2.988. Okay, that's the volume of the hyperbolic figure 8 knot.
2.02988.
Oh, 0.02.
Yeah, and then just hit enter. So if you knew the number was that roughly, but you only memorized that, say, or if you knew pi, you could put in 3.14159, right?
Yeah.
Now it tells you things it could be. Hit more. Right now, if I was looking at that one, I'd see the pi squared over 48 was kind of the only really interesting one, but hit more. Because we didn't put many digits in there.
Yeah.
Scroll down. There we go. Out of all your options, the simplest one is just the VFE, right? Now keep going down. So there's a symbol. I know you're like, well, I want to know what it is. Now it gives you the option to investigate. So find the VFE on the bottom there. Yeah.
What was this?
On the right hand side. Sorry.
Right. Okay. Snell's law.
Up a little bit.
Oh.
These are all what your definitions are. So you
can click the figure 8 knot hyperbolic volume.
Yeah. Click on it, and then click on definition, and then the investigation begins. Right. It starts telling you more things about the entire structure and so on.
Huh. You are going to make Professor Wolfram probably the happiest man in the world. Just because I even at one point I mentioned you did this, and when I was asking about knot theory, he kind of wasn't sure about what I was talking about electrons, but he went into knot theory, and this is what he was trying to do. This is what he's been trying to do with a lot of folks.
It is, and he's had a genius idea. He had the idea of trying to use the systematic ability of computers to search for equations and so on, right? Yeah, I did it entirely as a person, but it was actually a huge advantage as a person because I got to develop an intuition of when beautiful things would show up and when they wouldn't, right? I got to have little hints there that it'd be really hard to program a computer to have those intuitive hints ahead of time.
Right. Well, to have that intuition and then to have the ability to utilize the tools that we have of modern technology, I mean, you're leveraging like people and computers and stuff. And I mean, that just totally seems to be the future. Well,
hopefully that's how everyone does it, right? You use all the tools at your hand, at your disposal to make sense of the world the best you can. This is just really exciting because we've been at a gap ever since we've had that list of constants. We've basically made no conceptual leaps. Not that some people haven't proposed ideas and models. It's just none of those models have ever actually predicted these things. So it never made sense of them. It just hoped it could eventually, and that's where we were at. Now we have an entirely different way of introducing physics from the get-go, right? We can start right from mathematics, defining what manifolds are and explain just the simplest manifold, and then say, before we go further in math now, by the way, you now know the geometry of reality. That one manifold we just covered, it gives you all of physics. All right, now let's keep going in math.
well, that's, and one of the things that bothered me is certain things. Like I still remember in like high school physics and chemistry, and they're kind of just explaining. It's like, all right, you have an electron. What's an electron? Well, it's a particle, but it exists in all these places at the same time within these different valences. I'm sitting there like, well, that doesn't make much sense to me. Whereas you describe it, it's like, all right, it's a charge. You ever feel like, I don't know, static electricity? You feel a spark? It's energy. It's a force. And if you start to explain it like that, I'm like, that intuitively makes more sense to me. Now, maybe that's because I also grew up watching a lot of Japanese anime and stuff, and watching all these characters like shooting all like these spiraling blasts and stuff like that. But just in my head, I'm like, I can conceptualize that better rather than saying like it's boom, 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 boom. I'm like, that seems kind of weird.
That's an important factor too. When people give explanations that don't actually make sense of the question, you should keep in your head, that wasn't an explanation. It was an attempt for an explanation, but it didn't count.
And that's the thing, and what I have been noticing, just listening and just following the YouTube algorithm, because I truly think that depending on what we're consuming and stuff, the algorithm will lead us in certain directions. And then I'll go through some of your videos, and all of a sudden, oh, here's a video by Professor Whitten. That's interesting. Oh, here's something talking about like the what is it? Oh, the alpha zeta function. I don't know, all these different math videos. I'm sitting back, I'm like, I was never really a math guy, because I never really learned how to cross multiply fractions in the 6th grade, because our teacher said, you don't need to know this now, but this will be useful later. And then when I got to 7th grade, it's like, since you know how to multiply fractions, here are some letters and stuff. And I was all thrown off until I got to upper level, basically what was it, finance in college. All of a sudden, as soon as we put a $sign and a reason to calculate, all of a sudden it just kind of like clicked. It's like, oh, I know calculus. That and like nuclear physics for some. As long as there was an interest, as long as there was interest.
Yes, yeah,
exactly.
The thing is math ultimately is the fringe of all the space you would reach with true motivation, right? Math is the genuine reach for new idea. Everyone who's reached as far as they could has contributed a new idea in math, basically. There are other things you can contribute also, but it takes a genuine reach past the current horizon of humanity to contribute something new to math. And that's it's a really beautiful thing. Even if you don't usually apply the idea, having the access to the way of thought the idea allows is a sense of becoming. It makes you more.
Right. And I tend to be of the mind that even if that somebody doesn't necessarily generate an answer, we all affect everyone else as well. So all of a sudden, maybe just that quick conversation, or just maybe just that one small kindness you can do for another person might make all the difference. And that all of a sudden something aligns in their head, like, I was thinking about this, you know what, let me implement this into action. And then that affects other people. It's like, this is the one thing that I was looking for that this other person put out. And since we have the internet, it's like we don't necessarily need to write a letter or a telegram and then have like 2 months before we receive correspondence from another part of the world. We can do this.
Yeah,
exactly. And even if people utilizing this velocity of communication, very often it seems like, oh, we're doing it for whatever reasons. But I truly think that we can actually help solve these problems. There's so many problems around, some of them of our own making, some of them of just the universe itself. If we actually have the base reasons why things are the way they are, I think this can also help us explain ourselves.
Yeah, of course. That's the entire reason we're doing this, right? We woke up into a world not knowing anything and had to figure out how to have a thought, how to structure thought on top of that, and how to eventually figure out, oh, well, that thought I had before was wrong, and update it. There's a long process of figuring out what the world was. But the stage in history we were born into, right, already had clocks, it already had computers, and it had lots of things that most people didn't have. It didn't have ideas being presented to them regularly to just absorb as a kid, right? These ideas are relatively new here for us. That's a beautiful thing. Oh, I wanted to go in, because you asked, where is this going? It's already gone to the gamma function. It's, you're gonna, oh, it's so beautiful. The gamma function pulls apart internally in a beautiful, natural way. This has nothing to do with something, this is just something I've learned, not a new for me.
This is the thing that people said that could not be done.
Well, all of this is what said couldn't be done. The theory of everything was not supposed to be doable. But my point is, this theory of everything is a derangement, a minimal balanced derangement theory, right? Based on the hyperbolic figure 8 knot. If you have a balanced derangement theory, then you have to inversely be able to describe the thing as factorization theory. And the factorial function, more generalized, becomes the gamma function. The way that the factorials connect is defined by the gamma function. Okay, does that make sense so far?
I don't know what the gamma function is. I'm looking up right now.
Let's start with the factorial function. The factorial function we represent with an exclamation point after the operator. So n exclamation point. And if you took 5 for n, then it'd be 5 exclamation point equals 5 times 4 times 3 times 2 times 1. So you would always break it down into its sub-factors and then multiply them together. And that's the answer. So 5 factorial is all those multiplied together. A derangement, by the way, you take n and you minus 1 first, and then you take the factorial. Anyway, so they're directly connected. The gamma function expresses the continuity of that connection. Okay, so instead of just being defined at 1 and at n equals 2 and 3 and 4 and 5, the gamma function is defined at 1/2, at -1/2, it's defined everywhere on there. Okay, except for one point. No, the gamma function has no zeros. Next stage, the gamma function itself, which describes how things factorize, right, connects to the factorial equation, it internally pulls apart into two natural ways we call P and Q functions. And these are two-dimensional. So they have their argument as A and X or whatever, two different arguments. Well, if you put the unit, well, back up, if you add those things together, you always get 1. So it's a very symmetric way that they break up. If you take their derivatives, they're opposite of each other. So if you add their derivatives together, you get 0. So this P and Q parts are beautiful in the sense that when they're added together, they're just 1. When their derivatives are added together, they're just 0. Okay, but they are two parts that naturally balance that way. If you ask these parts, what is your unitary? So put in 1 for one of your operators, and generalized expression, put X. So we haven't identified it yet. And the answer is e to the negative x. It inversely generalizes hyperbolically. If you ask the other one the same exact thing, put in 1 and x for it, it's 1 minus e to the negative x. It's the reflection of the inverse generalized hyperbolic action. Now, maybe that was a faster jump. If I go real quick and just look at the hyperbolic number, E, Euler's number, 2.71718128. It's constructively harmonic and reversible, meaning it is the number that you get when you take the infinite sum of inverse factorials. Okay, so 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial all the way to infinity, you get E, Euler's number. Interestingly, though, when you have that sequence of what E equals constructively, the base construction of factorizations, if you take every other sign and turn it into a minus sign, then it's not going to equal E anymore. It'll equal something else, right? It equals 1 over E. It becomes its own inverse just by sequencing Mobiusly.
So we've got symmetry, yeah.
Yeah, if you generalize this E sequence, so E to the X instead. So before we were just saying E equals something, now we're saying E to the X equals that same sequence, but all the numerators have to have to the X added to them, okay? This generalization, this new sequence we have, if you take all the even parts and all the odd parts, pull them apart and then put them into separate sequences, then you get the hyperbolic identities, the hyperbolic cosine and the hyperbolic sine, okay? So we're literally saying here that this construction is hyperbolically balanced via E and hyperbolically decomposes via the gamma function under a reflection and a twist.
I don't know about you, man, but I'm starting to feel like one of those origami swans right now. Just all the different folds and everything, the intricacies and everything. Dude, I remember learning that in the 6th grade. I'm like, that was fascinating. It also has been the plot point of, I believe it was 2016's Shin Godzilla, as well as, how do we analyze this data? It makes no sense. I'm like, what if we folded it? And that was how they ended up subduing Godzilla for that particular time. But I know I brought this up on Wikipedia here, just even looking about the factorials, as well as, where is it over here? The pi, the gamma and pi functions here. And I'm looking over here, I'm like, all right, this kind of seems to have a certain form of a balance here. And again, like you said, it's not hitting 0. And I'm going through there, I'm seeing E keep on popping up as well. And we're just going through this, and I'm looking.
All right, let's go back to Wolfram Alpha now. So you know about this function. Let's go see what we do as our investigation. It's a fun little way for an individual to try to then learn the next thing without having to have a teacher around. It's a really big step to have in life, right? All right, so type in, get rid of the number there and type in gamma. Yeah, it likes to do that jumpy thing to you.
Do we want to delete this or?
Yeah, delete that. Type in gamma and parentheses and then close parentheses, and inside the parentheses put x plus iy.
X plus iy.
Close parentheses, and before gamma put plot and then space. No, no, just plot and then a space. Get rid of the.
Oh,
Not,
yeah, yeah. Okay, gotcha. All right.
yeah, good. Let's see what we get.
Means imaginary run unit there. Okay. I remember this from being in your video.
Uh-huh. Now, keep going. You might be like, oh, okay, that's kind of cool, but I suspect that if I zoom out, I might see something interesting. So if we want to zoom out, you can give it its parameters, like how far do you want x to go, from -1 to 1 like it is, or do you want to go from -10 to +10? So you can do that too and zoom out and see what it looks like. Play around with it, zoom in, zoom out, you know, and develop an intuition. Ask whatever questions press into you about it.
All right, so okay, so I would enlarge this,
No, go up to the top again.
Okay.
Yeah, and then, so at the end, put your cursor and then hit comma. It's a good thing to know this introduction, space. And then do the squiggly brackets. So the squiggly brackets will tell you the spacing here.
Yeah.
So x, so you know the parameter, comma, -10, comma, 10.
-10, comma, 10.
We just told, we could also, now close the bracket. We could also then stipulate for y if we wanted to, but it's going to make it symmetric. So we're only stipulating for 1, okay? And then you can go back and now change your -10 to anything you want each time.
Whoa! This is well, okay. There's stuff and things going on, man. There's stuff and things going on. This is wow. Okay, all right. We only saw this tiny little part here because the bounds is only 1. Huh.
Yeah. So if this was your introduction to the gamma function and you knew nothing about it, you'd never heard about it before. By the way, we're not really taught anything about it in physics. A few physicists are at the upper level, part of physicists, but most physicists, I think, aren't even told anything about the gamma function. So this could be your first introduction to it, right? What would be your impression? What do you think you're seeing?
It looks like from some very simple basics, when we continue to iterate out, we can get a lot of complexity.
Okay. But remember, this is a fundamental function in math. It's not just a fun thing we made up because it looks pretty. This is as fundamental as it gets as a representative of the things that partition.
Okay, so there's a certain level of intuition we could draw, because I know what that intuition is? Not at all.
No, but it's good to investigate. Yeah, if you could scroll down, what do you see different when you scroll down them up above? You get to see that these planes are divided in a certain way, right?
Well, these ones down here, these are 2-dimensional. The ones up here, these are 3-dimensional.
Yeah, the bottom ones are looking straight down, and it makes it easier for you to see that the division planes that are actually, so that's above applies also. You just don't see it as well. Well, of course, above you see the ones that stick up really well.
Right.
It's not the ones that are planar. Yeah. Okay, so this is like, you could think of a sheet. You could say I have a relationship in a plane, but the relationships I'm going to maintain in this plane need to be not just always statically maintained as a plane. What other relationships can we hold? Well, if we're going to twist the sheet up in a certain way and get things to fold against each other, they need to do it so they don't ruin the sheet, right?
It sounds like roughly you're trying to say is, this is why we're here right now.
The gamma function is incredibly central to the organization of anything that persists. Anything that's self-responsible, self-maintaining its own boundaries is central, and boundary 2 is a balance of the gamma function. It is a division balance. And you think about it, if your boundaries, if you're not being maintained externally by some active thing that's making the boundaries, if you're a system that's maintaining your own boundaries internally, then you have to find a way to partition and be rotating them, right? You have to keep doing a cycle that does that. Yeah.
You got to just continue on. So, here we go. Dad, look what you've done. There was mind exploded. The Love Shack, my mind folded and blew up already.
Yeah, actually, the more complicated logic of how we fold things and so on into nuts and even more complicated things like proteins and all the way up to our nerves and cells. Yeah, that's a way to go with the conversation. That's not mine's all been fundamental focus. But if I live a long time, I want to get this to go all the way to consciousness in a clear, objective way where we get direct access to understanding what the system is, and therefore a more clear way of interjecting with the system and manipulating it to how we want it to be. right? It's much easier if you know what the system's already doing and you want to manipulate it than if you just interacting with the black box.
Right. No, I'm not really a math guy, but all I know is the more parameters we have, the more information we have, the easier it typically is to solve for the other ones.
Mm-hmm.
So, all right, my man, where do we want to go from here?
Up to you. I mean, I'm still pushing towards understanding everything about all the factorials and to go into the primes. It's still getting the depth of the mystery there, but I know this has to answer the same mysteries there because it already got the gamma function. I haven't shown you, but I'll leave that for the next video and next book that's coming out because it's actually coming up soon. And that'll be the new big surprise, since I can't surprise you a second time with the theory of everything.
Oh, no. By all means. But when I just keep looking at this and just the sheer fact that it just seems so simple with just so much of this going on, it's like, how do we figure this out? It's like, well, we'll just start factoring. What is factoring? It's like, all right, 1, 2. We're just using these very basic things that we seem to cover maybe at one point and then just forget about for so many years. Because I hear that and I'm like, I remember those words in school. I don't remember hearing them for about almost 30 years now, but it rings a bell. And it just seems so fundamental. It just
Let me give you an insight of where I'm going with. I haven't worked out a full argument and don't have a full one yet, but this is my reach right now. The question of what the primes are. Do you know what the definition of primes is?
Is it? It's a number that's only divisible by 1 in itself, I believe.
Exactly, by itself and 1. All right. Why do we include 1?
I thought we didn't include 1.
No, we do as part of the definition.
Is it?
Yeah, you just said it.
No. Okay, the reason I say it, the reason
divisible only by itself and 1, but dividing by 1 doesn't do anything, right?
I feel like you're gonna tell me it's gonna do something now. Okay. No, the only reason I said that is because I was listening, and maybe it was an older video. Those are those three blue plus 1 brown video. He does a lot of math videos, and for some reason he said we don't count 1 as a prime. So I just took that as gospel, literally, because I heard it probably about an hour ago.
Sure. But the definition of any prime is being divisible only by itself. And
okay.
And I'm asking, why would we insist that we include the 1 if dividing by 1 doesn't do anything? It seems like meaningless information to attach to your sentence just to make it longer, right? It's not. The point is, oh wait, go ahead.
No, we need, well, I would say by the definition we're giving, it's like we should include 1 because that's my base thing. Because when I would say it's like, all right, the hyperbolic figure 8 knot, if you have 2 internal components and 3 external, aren't those kind of like the 2 of the lowest as we know them? Because at the same point, I'm like, shouldn't 1 be prime? Because they were saying 1 in itself. If it itself is 1, you're dividing it. I don't know.
Yeah, well, one is a prime. It's just not an interesting one usually for our mathematicians, right? Okay. So they just note, hey, we're ignoring 1, and this sequence that goes on for, and so on. But it's anyway. The 1 has always been a big mystery in math. I mean, if I were to wrap up in a really short paraphrase version of what the question fundamentally still is in math, okay, it's almost parallel to the fundamental questions in physics. It's, what is the grid? What's the space that we're mapping? What is this XY in which all of these rules of math work on? Okay, that hasn't been explained. It's a big, huge mystery in question. And the interesting thing is the grid, we know that there is a grid with the match all working. We know how much levels of math are working. We have plus and minus that are allowed operations, and symmetric multiplication and divide, except for the point 0, everywhere else it works, right? But every other operation we add, we have to make a new exception. Okay, there's an interesting, the grid doesn't allow these operations to be perfectly symmetric everywhere, but they work most places. So we have to make sense of why this math works on this metric. What is the actual metric? Well, some people would like to say, well, if we could find a way to twist the metric so that it's making sense, right, then it would make more sense to make sense of the math. But if you twist a metric, then all of its points are screwed up, right? However, it's been shown that there are ways, interesting ways, to rotate a metric several ways so that its points, 1, 2, 3, 4, all the grid points stay the same, but all the connections in between don't, right? And what operator do we need to do that? The gamma function. All right, kind of see where we're going here? We have a hyperbolic figure eight knot. We've projected a domain, and pretend we're talking about a universe now that only has one of this balance involved, okay? There's nothing else. It's the simplest, just one of these, not our actual world that's intersected with many, many of them. Okay, in that balance, let's see, it projects, or if you're only looking at that domain, then that domain is a universe. And what's the balance point? What's the one? What's the reference frame most natural to that universe? It's the reference frame in the universe that's the most stable, right? That external projection is the middle action of the last boundary. So in the temperature domain, that outer rotation, the middle of it is just the one. The one what? The one compared to this system, the one of this system. Now, why do we care? Well, because the system is literally defining a one that decomposes a very specific ordered way. A geometry of decomposition of one. That's what the system defines. And if you want to talk about things that are allowed to decompose together uniquely, at minimum, they must balance at least with the hyperbolic figure eight knot.
Whoa, yeah, the chat is losing their minds right now. They're going, oh my God, not the gamma, don't twist the metric. But I'm thinking about this, and I'm sitting back and I'm like, okay, because it seems very often once we get up to a certain point, whether we're trying to figure out, do singularities exist? What's happening in a black hole? Because I use those words interchangeably, and apparently that's a big no-no, and now I know that. But as far as just trying to figure out mapping things on, if we got to start to just add or try to subtract things, it's like, well, now you're shifting everything now. You need to have something that functions across a spectrum of basically all our reality, have it be consistent, have it make sense. And what it's kind of sounding like you might be hinting at, Thad, is just the sheer fact that if we're going by some twisting, whether it's a Mobius-like or just even just electromagnetic-like, just shifting along, if we're maybe even following that, even using the math, that might provide a better explanation.
Well, if we have a system that inherently gives us an explanation for what it means to factor, what it means to exist under factorization, that's what this system basically does, then that system generally is the one. So we can start with a conversation of how to build things unique. And every unique thing that can be composed of that balance becomes a prime.
We're back to the primes. We're back to the primes. They always keep coming up, man.
Well, I mean, that's where I'm reaching now, because I mean, I answered the questions I was after, turns out, in physics. Not completely, I still have questions I can't ask, right? But the ones I focused on were the fundamental ones. And it's so universally simple and complete from a single geometry that it's not like I'm carrying any doubt anymore that I should wait to figure out. This one satisfies it all at once. It's very beautiful. It's very intuitive. It's very visceral. And that's what I was after. But as soon as I had it, I realized this isn't the end. This I have to keep going from here, because this now makes sense of things that I was barely introduced to in college, and now I need to go apply it to them.
Well, that was the thing. 'Cause I remember when I was finishing up high school, I knew almost everything. And then I got to college and I started to learn. I realized I didn't know a dang thing, man. It's just because the more and more you learn, it opens up more and more avenues. And that was one of the reasons why I wanted to have you on, because it kind of seems, at least in my opinion, that you've basically at least shown us a path, at least a glimpse at just a new valley for humanity. Just one of the things that Einstein was looking for. It's like, listen, we're not done yet. And I feel very often folks in trying to show homage and show respect to Professor Einstein, they're just kind of saying, no, this is it. It's like he said himself, we're not done. We need to continue onward. It's the story of humanity. We got to. You
honor Einstein by continuing the quest that he cared about more than anything else. Yeah, and he cared because he had a greater depth of humanity, in my opinion. Right? He was reaching to actually understand, and through that reach of understanding, change what we are. That's caring about everyone. Yeah.
Right. No, I agree, and this is why I hope this is going to be a form of a basis of just for us to kind of at least transcend our bounds where we are right now, whether it's just
who knows what it's going to lead to technologically too. I mean, think this is basically saying it should be possible. Well, it's possible according to this theory to do 5D printing, right? If you can make a machine now and there's 5 boundaries and you can make the machine intentionally intersect those 5 boundaries, then the only thing that matters now is whether or not you have sequence control. Can you do this one first and then that one? As long as you can sequence control the boundaries, you can build anything that's ever been made, anything that persists, anything that does, anything that can persist. In fact, you can find the logic space there mathematically to find how to build things that haven't been built, right? Finds semi-stable orbits and paths and so on like that.
Well, that's the thing, just as far as either just advanced polymers, technology, lightweight materials and everything, if we could open it up and just reduce the cost rather than having to go through all these experiments and hoping things are going to work, if we can just start, because I even know with a lot of the Wolfram models, they've been doing a lot of stuff with advanced chemistry and stuff, trying to see how things can go together so we can use more efficiently the resources we have. That could unlock potential to, I don't know, maybe actually traverse the cosmos and maybe utilize other resources while we're on our way there and everything. It gives people hope, because right now I feel like so many folks just around the world, they just feel like they're in a rut. There's no hope. And I
think there's a stronger element of hope here, not just in, maybe the technology of the future will be better, but in the reopening of that biggest human noble quest, right? And in a sense, you could think Einstein was a genuinely as noble person as you can be. He was reaching for more, and he knew he was going to die. It's not like he get to keep it all, but that reach is extremely noble. And most people today they've been discouraged from doing it, been taught and just somehow convinced they're not smart enough, or the conversation somehow is framed that way, instead of realizing that it's not about being smart enough. It's about the fact that you recognize you're not. Right? It's realizing there's somewhere better to be intellectually. There's something else to know, to notice, to be more comprehensively aware of your surroundings, or to understand why things work instead of always be confused all the time. Right? That level of hope of being able to engage with the world and investigate and find for yourself is, I find, entirely inspiring. I wake up in the morning with a new question immediately before I even put my contacts in. I try to scribble down on a paper I left to try to, just so I don't forget it before I put my contacts in, right? It's exciting to participate in asking questions that you might get to find an answer. It's finding the question that's hard now, right? And that changes the game. To realize, hey, I just need to identify the questions of my own ignorance, to sharply identify them. And then we have the Google the universe, right? We can search, you can make a step. Yeah, it's really nice.
Right. And that's the thing. And just the ability to utilize the technology we have to continue to build, and as you said, to continue to generate questions and just reformulate those, because I'm totally going to use that Einstein answer that you had given before. We're going to spend 55 minutes figuring out what we're actually trying to figure out as precisely as possible.
Exactly.
And then we'll make the solving of it actually a lot easier there. And that just, it feels so often that we're just like, we have to do something. Let's do this. It's like, how much time did we spend? And in some instances, yes, you need to have action. I get that. But if you're trying to solve for these things, and if we have the time, why wouldn't we try to maximize it? Why wouldn't we try to reach out to different people and everything? Because I truly believe we don't know where a good idea may come from. And just even the ability to just reach out to different folks all across this internet of stuff and things, to be able to use the Wolfram Alphas, to be able to use the Googles and everything like that. It can just take you. I still even remember in college, one of my friends, he was a chemical engineer. We would just hop on Wikipedia. We'd be out throwing back some cold ones and stuff, and just go where we're learning about buckyballs and everything like that, and just carbon nanotubes and everything. Could you do a space elevator? And it's just an exercise, just working your brains and finding out what might actually be possible. And even if it's not possible now, maybe in the future. And you know what? Even if that's not the way to go, maybe we'll end up deriving a new question that might be useful for something else.
Yeah. And the search for new questions is literally just the search for more understanding. It's our individual path of growth. So it's not like you need to be personally incentivized. You just need to remember, that's my way of going.
Well, we all walk our own paths in life, and your path is much different than my path. My path is much
Yeah.
different than
Thank
everyone out
goodness.
here's path.
Yeah.
And well, exactly, because otherwise it's like, well, what's the point? We
Yeah,
all fit into
we'd
this
only at
humanity.
most notice the same things.
Right. Well,
Yeah.
even the example when you were correcting me yesterday, just saying that's like, no, dude, I wasn't using the paid version. I was just using the free version of Wolfram Alpha, because I did that video, and at the time I looked at it and I'm like, just my initial response, oh well, he must have the fancier version or something there.
Yeah.
That was
It's
what
so
was
easy
true.
for any distraction or any doubt usually kills a conversation. Right? I think it's a big thing we should bring up in the world today. The way you encourage conversation in human development is to create spaces in which it's safe to come up with an idea, right? Most ideas are wrong. It doesn't matter. The goal is to come up with a new idea, because only from new ideas can you sift to do something with. But if anyone's around judging or trying to, force doubt, that's the way the listening is. They're trying to find out why you're wrong. That you're not going to be coming up with new ideas in front of them.
This is something. This is why I'm very poorly attempting to derive what I call modern mimetic theory, because I'm sitting here, I'm looking at all these things, I'm learning about different tensor networks and everything, and I'm like, all right, well, if basically the universe as we know it is made up of a bunch of wavy particles, and we are made of wavy particles, could we not apply similar frameworks that we have within math and physics to us as well?
Mm-hmm.
And maybe even if we're doing it on a more aggregate level, to just try to communicate. So I'm just like, what you were just saying right there, if someone is utilizing a mimetic tensor of doubt there, it's like, oh no, you're obviously wrong. That's going to be adding a pressure there. And depending on the person's situation, everything, they might just try to snub that particular idea out of their mind. That idea may have actually led to the proper question, which would have advanced society ahead an extra 50 years. And while we might need to wait another 5 or 10 years for someone else to maybe think about that. So
It's
that's
very
kind of
true.
how I
Very
conceptualize it.
And the person who's saying you're wrong, they really should remember, if you're sure they're wrong before they finished saying it, you didn't listen. Right? The goal of listening isn't to find out whether someone's wrong. The goal of listening is to understand what's being said. After that, you can decide whether or not you want to, judge it. Yeah.
I love that right there, because that describes so many of my interactions on the internet. Just because I often try to be, somebody will say so. I feel like if folks are hitting on a topic a little bit unjustly, they're uncharacterized a little too much, I almost feel at times like I need to almost kind of take that point, even if I don't necessarily believe in it, because it's like, no, you're being unfair. So all of a sudden it's like, memes, you believe this? It's like, I didn't say I believed it, and I'm just going from as logical as I can to try to explain why some of these folks might be saying these things, and apparently I hit a particular button on you, and now you seem to just kind of be attacking me. We're delving into ad hominem and stuff now, and I'm like, what you just said of, if a person needs to say you're wrong before you've even finished, they haven't even listened.
Yeah, they're announcing to you that they are unwilling to listen. So yeah, just move on.
Yeah. That's why. Well, see, for me, I'm not smart enough to do that. Bad. See, I like a bit of banter, and this is why I try to keep it, because I find very often, just what I've noticed in conversations, because I've had some conversations with some controversial people, and very often some of my friends will be like, oh no, this person, you can't get through this person. And I look at some of their text-based conversations, again, a lower dimensionality than we are via video and audio right here. And very often I'd see at some point somebody would use a little bit of profanity there. And now maybe that's what they normally do, but at least growing up back in the day, occasionally we would say those were fighting words. And if you're on the internet, well, don't expect somebody to come back, and then it devolves, and you got people cursing and blocking and doing terrible things to each other on the internet. And I sit back, I'm like, let me run to these people. Let me say, hi, sir, or madam. Let me try to say, please, thank you. Maybe apologize, like earlier, since I was late, that I apologize for being tardy. Just treat people how you would want to be treated. Just, I don't know. It just seems to work.
Yeah, and it seems to be the more we learn about reality, the more we understand how we're all interconnected, and how the more you have that understanding in you, the more you naturally have empathy, but also a better alignment for all of us. So, yeah.
Right.
Cool. Well, anything else you want to cover?
You got me wanting to go into philosophy, man. It's just because I just did, as soon as you said just philosoph or physics philosopher there. Oh God! Now I'm under pressure to try to formulate the question. Usually I got a million questions. Now I want to refine it. Oh, this is a tough one. I know you're very busy. Have you finished 44?
No, but I might be a week or a week and a half away from sending out drafts. Do you want to read the draft?
I would love to.
Okay. Yeah, so it's pretty close. I got basically 7 pages that I don't like any of the paragraphs in. I got to fix it all. But other than that.
And then did you say you had a following book that you're planning to come out with after that, or?
Well, after that, my plan is to then do the audio guided reading of it, because then I can add a whole bunch of layers of explanations of the figures verbally, right? And then I'm actually intending to try to make a 15-minute animated video, but my animation skills are not the best in the world. So I'm trying to make a presentation that's 15 minutes and does the entire theory, all the numbers, and shows it all, and yeah.
You may want to reach out to Jen, because at least she has something that she has as she's proposing for perhaps the origin of life in God's universe by entangled photonic wave functions. She has probably about I think a 4 or 5 minute video that is probably the best explanation visually I've ever seen.
She made the graphics?
I believe so, or at least she has access, or could maybe. I mean, I could ask.
Yeah.
I know
I'll
occasionally.
make the best version I can, because I'm going to go to Berkeley when it opens. Oh, I'm so happy that the world's almost back.
Oh, wait! Which?
What?
East Coast Berkeley?
West Coast.
Or my West Coast. Okay, when I hear Berkeley, all of a sudden I'm sorry, because I'm thinking I'm over here on the East Coast. I'm like, wait a second, we got a bunch of B schools. We got Babson over here. We got a Brandeis. Okay, I'm sorry, too many B liberal schools. So
yeah, I'm going to go crash Berkeley for the opening, and I've been desperate to be in an environment that is designed to be full of people intentionally trying to learn, and with organized experts in certain topics, so who to go ask questions from. It's not like you can just go to their houses during COVID,
Yeah. No, it is nice that the world is finally starting to open up. Okay, let me wrap up with this. What do you hope we take away, just we as in the collective of humanity, from what you're working on?
I hope people get more enthusiasm for the adventure of consciousness. I want people to really grapple with, wherever you're currently at, however you currently define who you are, doesn't at all have to stay the same. In fact, I would like you to explore the idea that it's always best to intend to change it. Always. On purpose, for improvement, right? To reach out to become someone more. Instead of investing in convincing the world that you're currently the best, so they'll give you money. Instead, recognize viscerally to yourself that that's a wasted conversation, and reach for where you want to be better, right? Realize that it's not a bad thing to recognize you're not everything. Of course, that's the first honest step. But identifying and actively looking for ways in which you want to be better is a beautiful, beautiful thing. And I think, I really hope that this might encourage some people to realize, who are terrified of math or terrified of exploring the world through science because it doesn't make sense, it's too much to keep track of, it's too confusing, to maybe go back now and look at the whole world through a simpler lens and develop a different intuition, develop an excitement to explore the structure of the world and to ask questions. Literally, we're at a new frontier right now. This is a model that makes sense of the structure, the internal dynamic connection of quantum field theory. It gives you a visual picture of what's going on, right? And that picture is making sense of mysteries we've identified as the most central mysteries of our existence. Obviously, I'm not going to be figuring out how to apply them all. Everyone in the world is capable of trying to figure out this new idea and applying it to something, because we're talking about the model of physical reality. It's not like we don't know it doesn't apply to things. Right? So this is really encouraging. It's what Einstein was looking for. And if you haven't really investigated enough to know why he wanted what he was after so bad, then I'm trying to tell you, there is something waiting for you to discover in existence that's more exciting than anything you've ever felt. Okay, and that's the door into what the rest of it can be, the door into understanding something. Right now, you're probably trapped in the world that we were given, where if you imagine the universe, but now delete all the stuff you know about the earth, all the matter, the sun, all that kind of stuff, just delete it, empty it. How do you describe it? What are you imagining? If it's an infinite emptiness, that's really vague. You're very handicapped by that vision. We've all been very, very handicapped by that vision, because that means you live in a world with no explanation, not even a description, right? And in that world, all the elements that show up are pure magic. Pure magic. You have no visceral understanding of why they're even there, including your own hands. You're confused about everything in the world from the bottom up. If when you think of the universe itself as just that vague picture, we can now replace that with a very specific, accurate geometric form that then mathematically predicts all the constants. So we can verify to our best precision of measurement so far that that form is really structured that way. It gives you a way to explore the world in a way we've never even tried. Well, I can't say tried, in a way we've never had a window into before, right? Everyone that's really tried this topic is trying for basically this. This one magically just automatically does it. It's not like we have to say the world is made out of the simplest partition balance and the third one somehow intersected. It's just the simplest one. Yeah, anyway, that's kind of a rant, but I really, for me, it's extremely passionate to wake up and think, today I have another chance to ask a new question, because I have a method for finding the answer if I can come up with a question. And when I ask the question, I go look, and I find it might take me 10 minutes, it might take 20 minutes. It depends on how clear the question was in my head, right? But if I find an answer, I don't even necessarily need to understand the answer. It could be 4 pi divided by some other constant that I've never seen before. I can go look and see the constant is, and now I'm learning something about reality, right? On my own. That's a freedom that I think ennobles humanity in a way that we hadn't quite been before. And I really want to see everybody grasp the passion that can come from that, because you don't need anyone's permission to become something better. You don't need anyone's permission to learn the thing that you currently think is the hardest thing to understand. In fact, why don't you make a list of those things, and next time you feel a little emboldened, go look one up, right? Slowly knock them down. It's a really, really fun path, but it's a path that you have to commit to knowing, I don't know everything. That's why I'm on this. And anyway, yeah, end of rant.
No, I love your passion. That was one of the things that I noticed as well. The sheer fact that you're helping provide us with actual reasons why the standard model appears to us the way it is, opening up a new valley, Einstein's new grove of all this different potential fruit that we could actually harvest and continue to extend and grow humanity throughout the years. And I just love the passion and the message, because like you said, we're all connected, and I can't really think of a better way to end this. So, hey.
Well, it's good talking with you. Thanks.
Yeah, no, thank you so much, Thad. Peace out, everybody. Be safe. Thank you all for watching. And you know what? No matter what you do, some of Thad's advice could apply. Write it down, look it up, because you never know what you can contribute to society.